This is 1.1 naming binary ionic compounds. The first thing you should know about is cations and anions. Cations have positive charges. That's going to be your first 2, 3, and sometimes 4 groups on the periodic table. And anions have negative charges. That's groups 18, 17, 16, and 15. And if you look at a periodic table, it tells you the charges that all the elements have. So the first group right here always has +1 charges. Second group has +2. Third group +3. The fourth group can actually be plus or -4, depending on the situation. And then it starts counting back down with group 15 at nitrogen. That's -3. Oxygen is -2. And group 17 is -1. And then the group 18 is called noble gases. Those don't have any charge. And so then, just for a few example problems, going from a formula to a name is pretty easy. All you have to do, for example, if you're given NaBr, you just look what the two names are on the periodic table. Na stands for sodium, and Br stands for bromine. But actually, the thing is, when you name ionic compounds, you take off the ending of the anion, the one with the negative charge, the one that comes second, and you add "ide" to the end. So NaBr is sodium bromide. Whereas if you had, say, Al(I3), this is going to be aluminum, and then I stands for iodine, which again you take off the INE and you add "ide" instead. And you don't have to worry about doing anything with the 3, so it becomes aluminum iodide. And so then going from, so more examples of that would just be like fluorine would become fluoride, chlorine would become chloride, bromine becomes bromide, oxygen becomes oxide. Any of your negative charged anions are gonna drop their ending and add "ide" when you're naming ionic compounds. Now, going from name to writing the formula is a little trickier. For example, if we were given strontium fluoride, that's actually fluoride. Okay, if we were giving strontium fluoride, we look on the periodic table to see which symbols correspond. So strontium is Sr, and fluoride would be fluorine, which is F. And you just write them in the order that they're written, and then you have to look at the charges for both of those. So if you see on your periodic table, strontium is in group 2, so that's a +2 charge, and fluorine is -1, that's a -2 charge. And I think it's easiest to just crisscross the charges. So you're going to have Sr1 and F2, but you don't really need the 1 there. You can just leave it as Sr F2, and that's because the charges have to add up to 0. So since this is +2, but F is only -1, you need 2 fluorines to cancel out the +2 charge of strontium. So your formula is SrF2. One more example of that would be if we were given magnesium phosphide, Magnesium is Mg, and phosphide is P. And so if you look on your periodic table, magnesium's in group 2, it's a +2 charge. Phosphate is in group 15, that's a -3 charge. And so we have a +2 charge and a -3 charge, and like I said, you can just crisscross them. I think that's what's easiest, Mg3, P2. And if you look, you know that's right because it cancels out. You have 3 magnesiums at +2 charge, so that's like 6 positives on here, whereas here you have 2 phosphides at -3 charge, so that's like 6 negatives here. So Mg3P2 has an overall charge of 0, which is what you want. Yeah, and so that's all for naming ionic compounds.